Hey everyone, we're going to do a quick video on graphing trig functions in Desmos. You should have already seen the one where we did sine and cosine. I might just do a quick sine curve just to recap. If you want to do stuff like y equals sine x, right, it'll draw on your curve. You want to make sure you're in radians, and you often want to make sure that your step size is in terms of pi. I usually like to put in pi over 2 because that's when most of the stuff happens, unless you have a period change or a shift or something like that. But under normal circumstances with no period changes, no shifts, that's where everything's going to happen. Those pi over 2's or multiples of pi that are right there. So I usually change that step size and make sure I'm in radians, and then I'm good to go. All right, if you want to graph things like tangent, cotangent, cosecant, secant, and that sort of stuff, you can also do that in Desmos just by typing it. So on the calculator, sometimes you'll have to do like a 1 over sine for cosecant. But in Desmos, you can just say y equals cosecant, CSC, of x, and it'll graph it. And then that's kind of it. Now it doesn't graph the asymptotes, so I'm going to hide this sine curve real quick. So it doesn't graph the asymptotes, but it will graph all the rest of it. If you ever want to see the asymptotes, here's a kind of a trick that you can use. So I'm going to call this L1. This is going to be a list of numbers, and I'm going to use a square bracket. So usually that's over by the enter key. And then I'm just going to put in the asymptotes, which are multiples of pi for cosecant. So be something like negative 5 pi, negative 4 pi, all the way up to however far you want to go. So you can just type dot, 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 and then where you want to end. Let's say we'll end at 5 pi. Right, so this will be an 11 element list. Right, is what you'll see it display. So that means negative 5 pi, negative 4 pi, negative 3 pi, negative 2 pi, all the way till I get to 5 pi. Right, so it's just all the multiples of pi. And then I can say x equals that L1, and it'll draw in, right, all those asymptotes. And you can change it, right, if you want the usual dashed line, or if you want to make it not quite as bold or a different color, you can always do that, right? So now we'll make that a 2 so we can see it. So now those red dashed lines, those are going to be my asymptotes. If I want to graph something like cotangent, same deal. Y equals cotangent of x, right? We'll have those same asymptotes as cosecant. So both cofunctions, right? Cosecant, cotangent, are going to have those multiples of pi as the asymptotes. So that's just one thing that you can do if you're wanting to see the asymptotes, but you don't want to make a whole bunch of equations. You can always use that kind of list format that's right there. So it's your starting one, the next one that would be in line, and then dot, 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 till you get to the last one that you want to see, right? So we're going to see these all the way till we get to 5 pi, but then, right, not after that. If I want to do the other ones, so, or real quick, before we leave this graph, notice for this cosecant, this sine, their peaks and valleys are kind of matching up, right? So if I put in, say, an amplitude, like we'll maybe just make that A, add a slider. If that A goes to maybe like 3, notice that extends our sine curve, so we already know about amplitude and how that happens, but it also extends that attached cosecant curve. So a lot of times what we'll do when we're graphing a cosecant is we'll just graph the sine, we'll graph the equation like it normally would be if it were sine, and then just attach those peaks and valleys to each other, and then go away from the midline, right, toward the asymptotes. So a lot of times that's kind of how you'll see it. Let's go and make that one red and dashed as well. So all the ones in red you see are kind of those guidelines, right? So you got that sine curve that's a guideline, asymptotes that are guidelines, the only curve, right, that really is your curve. That a little bit thicker, right, is that dark purple, right? So that is going to be my cosecant curve right there. But it does actually help to draw the guidelines. So a lot of times if you're sketching these by hand, you'll go ahead and just, sketch a few cycles, maybe 1 or 2 cycles of a sine curve. Then you'll attach those peaks and valleys to each other. And then you'll just go away from the midline toward the asymptotes. And that'll be your cosecant curve. If you are doing a secant, it's the same deal, but with cosine. Right? So if I do cosine and secant, they have kind of that same relationship. So peaks and valleys attached. The asymptotes are not going to be correct for this one, so we want to make a different list of where the cosine is 0, which is those odd multiples of pi over 2. So I'm going to say list 2 are the other asymptotes, which let's start at maybe -11 pi over 2. It's all the odd multiples, so we'll just need another odd number, so -9 pi over 2, 2, and then we'll go ... Thank goodness I don't have to list them all out till we get to maybe +11 pi over 2. All right, so that gives me this time a 12 element list. Right, we're going to be getting a couple more this time. And now instead of graphing list 1, I'm going to graph list 2. Right, so that's at all the odd multiples of pi over 2, right? Pi over 2, 3 pi over 2, 5 pi over 2, all the way out till I get to the -11 and +11 pi over 2. So that gives us our guidelines for a secant graph. Right, so a lot of times, again, if you're graphing these by hand, go ahead and just graph the cosine, right? What I normally do with a cosine, put in your asymptotes, right, where the midline and the cosine kind of intersect, right? That's where you're going to put in your asymptotes, and then you're going to go ahead and just attach those peaks and valleys, go away from that midline toward those asymptotes. So that'll kind of be it. The last thing that we'll do here is I'll just graph a tangent curve real quick, just so you can see what that looks like. I'll change that color as well. And let's go ahead and hide my secant and my cosine curve. Right, so this is what tangent looks like. Right, it has that 0, 0 goes toward those odd multiples of pi over 2. And is always increasing, right? It's always, no matter where you're at, heading uphill. So that is our tangent curve. And again, you can modify that if you want, right? I can stretch that out by a factor of 2, and it'll stretch out, or I can put in like a 1/2 in front. That too. And that'll shrink it down so that bend is a little more obvious right there. But that is the idea. You're just typing these in. Don't have to do anything special like you do on some of the graphing calculators, like putting in a 1/, tangent if I want cotangent, or a 1/, cosine if I want secant. You can just type those functions right in. All right. Hope that was a helpful video, and we'll see you on the next one.